My name is Cassie Sofing, and I would like to welcome you and everyone else to our webinar today. Just a little background that we are recording the webinar and all the chats that take place. And if you'd like to look at any of our past webinar recordings, there's a link here, and they go all the way back. We're now in our 4th year, so we have monthly webinars going back for 4 years that you're welcome to take a look at. But while we're waiting for others to kind of join us and for us to get settled in, I know that there's a lot of good reasons that you've chosen to join us today. And if you wouldn't mind just putting 1 or 2 in the chat right now, letting us know why you've joined us, we'd appreciate knowing who's here. I just put 1 and thought it'd be a good idea to get us started. Looking at the attendee list, there's several folks whose names I recognize, and then there's several new folks that are joining us. If you'd like to just, thank you, Madini, is put your name and where you're coming from. Today we're celebrating Landsat with Peder Nelson. It's the science and history of Landsat, the legacy of 50 years of remotely sensing the Earth's landscape and connections to globe. And I'd like to introduce Peder Nelson. He is the science lead for the Globe Land Cover from Oregon State University, the College of Earth, Ocean, and Atmospheric Sciences. His background is in environmental education, biological sciences, and land management, and he uses remote sensing and geographic information systems to create maps and data that show people what's happening on planet Earth, particularly changes that can be seen from space. He's also the Oregon American View, is it administrator, Peter?
State coordinator.
State coordinator. I should remember that. Thank you very much. The state coordinator. Following Peter's presentation, we're celebrating reports from the field with Inês Mauad from Brazil, who has some wonderful examples of students using Mosquito Habitat Mapper in their classroom. So hold on, we got a great program for you. These are the websites that Peter will be using today. They'll also show up on our archived webinar, and we'll throw them in the chat as we go. If you'd like to follow along as he starts presenting, you can certainly do that, although he does move kind of quick, so we'll see what happens.
The Landsat series of satellites have been watching our planet for nearly 50 years, capturing changes on land and making that information freely available to users around the world. On September 27, 2021, Landsat 9 will launch from the Vandenberg Space Force Base located in Lompoc, California. It will enter Landsat 7's current orbit and largely replicate Landsat 8's capabilities to provide a seamless continuation of data, ending its 22-year journey observation of Earth. Building upon the partnership with NASA, the USGS will operate and distribute the data for the 7-year estimated service life of Landsat 9. Fitted with updated advanced sensors, Landsat 9 is equipped with the operational Land Imager 2, which will capture images of Earth in visible, near-infrared, and shortwave infrared light, and the thermal infrared sensor 2, which will measure the heat or brightness of Earth's surfaces. Capturing nearly 1,500 new scenes a day to support the USGS Landsat archive, Landsat 9, like its predecessor, will also image all global land masses and nearshore coastal regions, which were not routinely collected prior to Landsat 8. The Landsat mission is especially useful for teasing out land changes that could contribute to climate change, like deforestation, and those that are caused by climate change, like intense wildfire burn scars. The impacts of climate change will continue to cause changes in vegetation, wildfires, and species distributions. The Landsat satellites provides access to a suite of products in near real time, helping to look at the past, present, and future.
This is the next one, right? Okay.
My name is Robert Kennedy. I'm an assistant professor in the Department of Earth and Environment at Boston University. All of these images are numbers. Now we can display them on a monitor as different colors, but what we work with analytically are the numbers themselves. When we're looking at how processes affect landscapes, you need to understand how the processes unfold over time. Hindsight's 2020. Landsat gives you that hindsight. In the Pacific Northwest, known for its timber, right, for producing lumber. So you've got a stable forest, and it looks kind of the same to the satellite over time. Then you come along, cut down all the trees, boom, it's a lot brighter. And so you can think of subtracting one part of the information. And the other thing is that you've revealed something new, which is the soil, the rocks. We added this soil in there, this signal that it sort of bursts out at you like a flag. That soil signal that was there, that you saw right after the clear cut, immediately starts getting obscured. Grass will come in, shrubs will come in. So as that happens, the soil gets covered up, and so you can actually watch that whole process happen, from an older forest to this bright soil to recovering vegetation. So the progression in the bark beetle is we have a fairly stable lodgepole forest. There'll be sort of an explosion, an epidemic of these beetles. Our color scheme kind of goes from stable forest, which is in tones of blue, this bright red coming from the soil and from branches and things that are revealed when the trees lose their needles and when the needles change color. One of the insects that's increasingly important is a western spruce budworm. They don't go in and kill the tree outright, but come in and eat the buds or the young needles off a tree. And so the satellite sees that as a bit of a darkening of the picture over time. By the end of the time period, we see pure yellow, and that's associated with broadleaf shrubs. It could even be a shrub field, just dense. Those bugs have changed the environment for everything else there, and the everything else there in this part of the world are shrubs, rhododendrons, other shrubs that are usually hanging out underneath the trees where it's kind of dark and shady. Boom, they get all this light, they love it, they grow like gangbusters. One of the interesting things about managing forests in the Pacific Northwest, you can see a very strict delineation on your landscape from the satellite's perspective, and that's just a manifestation of the policy differences, of the ownership differences. The idea behind science is to develop understanding, ultimately to be able to predict and understand process. When we look at a change, when we look at those graphs of life histories of individual pixels, it's the numbers that drive everything. It's the numbers that we use to look at how severe things are. It's the numbers that we use to quantify how long did it take, or when did that start, or how big was that clear cut. The Landsat perspective is really the only tool that lets you look at what's going on at the scale that you're interested in, where you can see individual events and harvests and roads and houses, and at the same time look at the whole landscape.
Thanks so much for running those videos. I hope that gives you all a sense for some of what we can do with science and what we can do with this type of data, and might get you a little excited about what I'm going to talk about today. I am an instructor of geography and geospatial science at Oregon State University. And before that, I also spent a lot of time researching how to do exactly what Robert Kennedy talked about, because I was working with him, which is one reason why I really like showing that video. It talks about the work that I've been doing for about 15 years now. And what's really exciting is that there's opportunities for everybody here to be involved in that science now too. And so with the launch of Landsat 9 and all of this new data that nobody's looked at before, what kind of science are we going to be able to do together? And to me, that's a really exciting opportunity for us to consider. Right now, nobody's looked at any of this Landsat 9 data because it hasn't come down yet. So students in the GLOBE program and part of Mission Mosquito here have the opportunity to do novel, unique science because nobody is looking at those pixels that those students are going to. And importantly, as Robert alluded to in that video, putting the present in context of the past, helps us to understand how what we're doing to our environment might make mosquito habitat in particular much more prevalent, and therefore make us as humans who are living in those environments much more susceptible to getting bitten by those mosquitoes. And so, even though what Robert was talking about with forests and some of those changes, you may not see the direct connection to mosquito habitat, right? But it is important to recognize that, as something I've learned from Dr. Rusty Logue here, is that mosquitoes need vegetation. They actually eat vegetation, and that's one of their primary sources. So it's not just the water in the landscape, it's also the vegetation in the landscape, and where is that vegetation located? Is the vegetation spaced close enough that a mosquito can actually fly from one tree to another tree, or from one shrub to another shrub, or even from a grassland area to another grassland area? And so, going out and just observing your environment, documenting it using my favorite tool, the Globe Observer Land Cover tool, allows us to put what we're measuring with the satellites in space into context on the ground as well. And this is important because there's a lot of challenges of trying to see mosquitoes from space. One of them is the atmosphere, and clouds are really a challenge if you're trying to map out features on the ground. And so that the amount of clouds, when clouds occur, where they're occurring, how big the shadows from those clouds are, all are challenges that we have trying to use this type of data from space to understand what's happening on the ground. That's, again, why having those ground photos and that information coming from the Globe program and the Globe Observer mobile app really help us to fix or remove that atmosphere, or to observe when a satellite can't. And that's a really important feature, that where mosquitoes tend to be some of the biggest problems, you also tend to have a lot of clouds producing rain, which then also helps to drive photosynthesis and why we have vegetation, and the robust vegetation in certain areas, right? So I wanted to provide that little bit of context because it's this connection between where you're finding mosquitoes, or where you might be putting a trap out, or where you might be observing. We really do need to have that context, that land cover context about what's around that trap or that location where you're finding mosquitoes. And by doing that, we're then able to use this wall-to-wall, a term we use when we actually are able to have a map that runs from the coastline to the other coastline, and we actually have measurements across the full landscape or our full area. We, as globe observers or scientists on the ground, rarely can measure every single one of these pixels, right? So one of the things that we do need is ground data. We need information on the ground at a variety of pixels, at a variety of colors of the landscape. And that color, like Robert mentioned, is how remote sensing scientists like me are tracking changes. It is that color change that we're actually able to measure on the ground using our digital cameras, as well as from space, where we're doing the same thing, digital images from space, but from a different perspective. So all of this is really exciting. It's an exciting time because, like I said, rarely do we get the opportunity to look at new data that nobody else has looked at before. And I can guarantee nobody's going to be looking at the pixels that your students or community could be looking at. There's going to be a lot of people who are bringing in all of this information. They might be doing some statistics off of it, some things like that. But to actually look at some individual pixels and describe the life history, as Robert was describing in that video, is a really unique opportunity that we have right now in this moment. A year from now or 2 years from now, somebody might have done it. But this coming year, when this data comes out in January, this is a very unique time for all of us to do some really interesting and novel science. So as you can tell, I'm bursting at the seams, kind of, thinking about what those possibilities are. And so, what I want to share with you today is getting us to start thinking about this satellite data and how it might be used to predict or understand mosquito habitat. And importantly, I want you to start thinking about landscapes and what they're going to look like or be like 5 years from now. What kind of information do we need to know or have to understand mosquito vulnerability that might be there, or mosquito habitat? And this question of, is mosquito habitat changing over time, requires us to have a lot of data at a baseline, like right now, and then at some other point in the future. And so again, this is where satellite data, in particular Landsat, allows us to fill in some of that information between our on-the-ground measurements. And what I'm showing here is a recent peer-reviewed paper that was put out by Dr. Mike Wimberly, who has also presented here with the Mission Mosquito. And this paper just came out in June this year. So it's really relevant to our conversations here. But it shows you all of the different things that we actually need or could get from satellite observations to predict mosquito habitat, or to be able to describe mosquito habitat. And so this graph right here, this figure, it could and should possibly drive some of the questions that you have. And I hope when you look at this, you can actually start to see some of the globe protocols that are in here. Temperature, humidity, precipitation, that's all in that atmosphere sphere and protocols. When we actually are looking at mosquito habitat or mosquitoes themselves, right? We have this mobile app with the Globe Observer to be able to record that type of information. Land use, where humans are on the landscape, that's all sort of in that Globe Observer land cover, or the land cover protocols that actually describe a little bit about not only what's there, but how people are using that. And this important distinction between where people are living versus where people are working is a really interesting one, because when people are working in the forests or are working in some of these areas, they might be susceptible to mosquitoes. But if they're living somewhere, maybe they're safe because of mitigation efforts or other things like that. So we want to consider not only where people are living, but also where they're traveling through the day and night that might make them susceptible for mosquito bites, I guess, for lack of a better word. And so I hope, some of this is some nice scientific jargon, but you can see that precipitation, we can measure land surface temperature, spectral indices. So these are things like vegetation, how vegetated is an area, or how much water is in an area. Some of this information that we're measuring from the reflectance of sunlight off of the earth, right? So kind of right behind me, these really bright green areas are agricultural areas. Over here, these I guess more darker green areas are the forests. And then here we have some snow and glaciers up high. So, this type of data can be reduced and it can be quantified in a way that we can put it into a model or be able to describe our landscape. So you can see how much information it takes to actually describe mosquito habitat. So that is a huge challenge for us, right? But again, luckily, we've had these Earth observing satellites since 1972. So we're coming up on 50 years of having pretty continuous satellite observations that can actually help us to have measurements from the past when we weren't doing mosquito habitat monitoring, and we weren't thinking about some of these things. So the satellite data, like I said, can actually help fill in the gaps in between your ground measurements. And you can see that here we are down Landsat 9, and we are on this timeline of science. And that's really exciting to me because the GLOBE program actually started collecting data back here in 1995, before Landsat 7, Landsat 8, or Landsat 9 even came about. And so we have the potential to really impact or really use the GLOBE data together with this historical Landsat data. So again, really exciting because there's not many other programs that have that length of data. So contribute your data to the database. And that's how you can really contribute to science. Because when we start looking at the GLOBE database, you can look at it like this, how everybody likes to look at it. But you can also switch over and you can switch to the satellite view. And right here at this level, we are seeing Landsat imagery. And notice there's no clouds. That's all been removed. And so we actually are seeing the surface of the Earth, which is really useful. You can get other satellite data inside of here. And I want to highlight that because this is a really hard connection to make between this GLOBE data and the satellite data that we're talking about. So I wanted to highlight that piece of things, that you actually have some information right here that you can work with. And what we were able to do, we just finished up this Mosquito Habitat Photo Challenge, right? And what I wanted to highlight from this is the value of this point in time observation, where we actually have both land cover observations in a spot, and then we also have a lot of mosquito observations for those same locations. And by having these two pieces of information, we're able to actually use the satellite data and make some connections with that. But I wanted to kind of highlight, this is a really interesting graph of data collection, right? And you can see we had a lot of participation in about a week time frame. But then for some reason, we didn't get a lot of people taking land cover observations when they were taking a lot more of the mosquito observations. So this is a little bit of a missed opportunity where we can describe some of the mosquito habitat, but if we had that other information about the landscape that we're finding the mosquitoes in, that would actually help us to use the satellite data in a more meaningful way. And so I wanted to highlight that because one, I just want to say great job everybody who can actually take use of this type of data in the coming year, right? So where we do have land cover observations and mosquito observations on the ground, that then becomes really powerful and helps you to have more data that you can use. Remember, like Robert said, these digital images are numbers. So yes, it's a pretty picture. It tells a story, but there's a lot that we can do with those numbers. So that's what we've been doing together. And I wanted to now highlight a couple resources for you as you start thinking about the type of science that you can do with the GLOBE data that's been collected, but also thinking about forward-looking, what data do we need to collect, and what information might you want to have. I want to just highlight this Camp Landsat. This is full of all kinds of really interesting activities, lessons, videos that are really useful to understand Landsat and all the great things that we can do with it. And there's this launch party kit that you can get things like a 3D model that you can print out using a 3D printer, for example. And so there's a couple focuses. Some of the ones that we've already talked about, forest. But what I wanted to highlight is that week 9, flora and fauna. Well, that's mosquitoes and mosquito habitat. And so in this week 9 is a little bit more about how Landsat has been used for modeling and monitoring different types of habitat. In this case, birds. Birds and mosquitoes tend to go together quite often. And so this is actually a pretty interesting resource and might be one that you can use with your students to help them to understand this satellite data and make some connections with that. So, we have a nice little connection right here with learn how to be a globe observer citizen scientist. So you can use this, share it, and here is our connection between the Landsat scientists and our globe observer community. So again, I love this resource. It's really interesting. A lot of posters and games and things like that using this type of imagery. So lots of fun resources that goes beyond what I want to show you next, which is a little bit more of the data, right? So as Cassie said, I go through quite a few websites and show a lot of things. So definitely go back and watch this recording because one of the things that has happened since my last presentation to this group is that now in the NASA Worldview viewer here, you can actually get and see Landsat data inside of here. And so to do that, all you need to do is add a layer and say, I want to find Landsat. And then there's a variety of flavors that you can add in, depending on your geography. So there are some that are specific to just particular locations, but you should be able to use some of these to actually understand and see impervious surface, for instance, and several other layers. So this is, again, a viewer. It's not raw, it's not the real data, but it's a nice place to start understanding and seeing the raw data. So you can turn on this reflectance or surface reflectance. So I'm going to pause and ask a question right here, because it refers back to what I had mentioned earlier. So in the chat, can somebody just say what is the difference between surface reflectance and top of atmosphere? I'm pausing to let you think about this one. So since I'm not seeing a response yet, maybe somebody's typing, this goes back to what I was talking about earlier. If we want to measure things on the surface of the Earth, we want to be using surface reflectance. And this is really nice because the scientists have actually gone in and removed the atmosphere. And this was something that we previously had to do on our own, but it has become really important to recognize that if we are measuring things on the surface of the Earth, we need to account for atmospheric scattering and the way that sunlight might be impacted by that atmosphere as it's getting measured by the satellite. So you'll see in here, surface reflectance is the term with that Landsat data has. Top of atmosphere is it's fuzzier, it's muted because you have all of the atmosphere that is influencing the measurement. So really important if you want to actually get data So I wanted to highlight that because these terms showed up right here, right? So we need to understand the jargon. So I'm going to turn on this, just Landsat 8 right here. And I now have this nice layer up here. Turn that off. And now I should be able to see Landsat data. I have to turn off something else. But I don't see anything right now, right? And I want to highlight that because there is a little bit of a lag time between when the satellite makes its measurements and it shows up and is able for us to start working with it. Things are getting faster, but there's still a little bit of a delay. And so what you need to do is you can go back and just rotate back a couple days. And now we can actually start to see, here are the strips, the scenes and rows that make up Landsat and how it actually is collecting data. So one thing I want you to notice is the width, right? They're not very wide. And so that's one reason why it takes a while to actually cover an entire country or an entire region. So, it will take 16 days for Landsat to come back to this particular location. And that's why Landsat 9 is really important, is because Landsat 9 will visit this location in 8 days. So it will actually cut our repeat observation time down. So, this kind of information is really, really useful, and we can zoom in on it. And you can start to see the very high resolution clouds that are there, right, in this particular area. So that right there is really telling. And we need mosquito habitat measurements underneath these clouds in particular. But this is also a challenge for us. We can't see what's happening underneath the ground or underneath these clouds. But one thing we can do that is useful, we can count for this location the number of times that a cloud was in a Landsat image. That actually might tell us how wet an area might be. It might tell us something about humidity. It might tell us something about the temperature. It will usually be cooler underneath the cloud than out when you don't have a cloud. More sun is hitting you. So, this sort of information is really, really useful. And this is a great place to just start exploring and seeing what's available. And you can just rotate back through time and you can start to see where the data is available and what is there. Clouds, they're just annoying if you're trying to map anything out on the ground. And so luckily, Landsat data does come with cloud masks. And so that's actually a great research question. Did the cloud get masked out by what is provided? Future webinars will go into some of those details, or we'll provide some methods on the website about how to get a little bit more into the classification or identification of data. But I just wanted to mention a couple of these as interesting ideas that you can start to see in this perspective and with this particular data. One of the keys, though, this data here in Worldview only goes back to 2018, or I'm sorry, only goes back to 2020. And there's reasons for that, but just recognize this Landsat data has a time limit to it and a time frame if you're looking in NASA Worldview. So that's where, again, there are lots of places where you can get Landsat data, where you can see it. So I want to highlight one that I used, and I actually used it to create this map behind me, or this image behind me. And this comes from the European Space Agency and their Sentinel data, or Sentinel satellite series. So NASA's not the only one who realized that looking down at Earth is a good thing. So the European Space Agency, they developed a sensor that is very similar to Landsat, has the same measurement wavelengths, the same kind of similar characteristics. And so what that actually allows us to do is combine these two data together because they're very, very similar. And so you should be able to go here. Looks like in live, it is not loading for me today. But I encourage you to go to this website, and there's a nice tutorial that guides you through how to make a satellite image like what I have right behind me. And so since that's not working right now, I want to show you something that is really an important piece that comes out of this. And so, like I mentioned, there's a lot of data here. And one of the things that we are trying to do is reduce that data into something that is comprehensible, right? 16 days with observations times 30 years gives us a lot of information. So people have been taking advantage of Google's Earth Engine. And so Google has come along and actually copied the entire Landsat archive into their server system. So all the YouTube servers, everything that we use for search, all of those sort of things, they now have an area that is dedicated to Earth observation data. And so they helped and worked with some scientists to actually quantify for every 30-meter pixel across the globe that Landsat has observed, has there ever been water there? This water occurrence, sometimes water to always water. Is that water changing really fast? Is it increasing or is it decreasing over time, like from a drought? This question of water seasonality, this is really important one for our mosquito habitat. Is the water always there? Is the water there when it's warm enough that mosquitoes can take advantage of it? And then also, how often does water come back to a particular location? So, with this type of information, you can actually zoom in on a particular location. And what I find very fascinating about something like this is we can start to actually see and quantify those water changes. That again, if we're having drought and there isn't water out in an area that it usually is, what impact does that have on mosquitoes? Do we have a greater population or a smaller population? So I look at a map like this and say, well, I want to go sample and find out what's happening in these areas that are always water to the areas that are just sometimes water. And I want to highlight that, this is Landsat data, but it also it's something that you can work with right now, and you can access and you can start to use to inform where you actually want to do some research coming up in this year. So I wanted to really highlight this particular one because of this unique opportunity, the way they've taken all of that information and tried to make some sense out of it. So these are a couple of the tools that I wanted to seed out there to our community here, and see if that is something that you would be able to use, and to get you excited about the unique time period we're in with the Landsat series of satellites in particular. And the only way we can really understand climate change is through continuous observations like this that is shared amongst all of us so that everybody can participate in science. So thanks for diving into this, and hopefully we have a time for at least a few questions here before we wrap up my part of the presentation today.
Hey, thanks, Peder. That was just really exciting and really fun. And we hope to see a lot more presentations about land cover in the coming year with mosquitoes, because what we know is that this is data that mosquito scientists want to have connected to our observations. So it was so powerful to see that when we did our, our campaign, that there were land cover coming in, but they were not correlated to where people were also doing mosquitoes. So I really hope that message came through loud and clear. We did have one question, which is, when you showed all the different surface reflectance ones, how do we know which ones to choose? I mean, how do you know which data you want to look at? I mean, there's so much out there. There is so much out there. And can you make it easy for us to make our first steps in trying to access some of this?
Yes. So that is why I showed that NASA Worldview site. Is if you follow their tutorial, they actually have a little tutorial about Landsat and the surface reflectance, what it is, and how to select and which one to show. One of the things that's important is read the information tab that is with each one of those. And so that tells you a little bit more about the limitations, might be a geographic limitation. That's definitely a big piece. And so sometimes you have to try a couple of those different layers to see what do they look like. There's technical differences in the background about how well they remove the atmosphere. And that's why you do see some difference between a weld surface reflectance or a reflectance. But as you saw in there is no top of atmosphere. So any of those reflectance or surface reflectance data would be good to start working with inside of here. So I really appreciate that question, because this is an important one. Not all satellite data is the same. You really do need to understand what happened between the measurement in space, what some engineers did to it, and then importantly, who archived it. Did Google do something to it before they released it? Or did NASA do something with it? That's where you have to kind of read the information behind it to make some sense out of what somebody's presenting to you. Not all satellite data is the same. Go to the source. Go to NASA, go to the US Geological Survey. That's my recommendation. Yes, Cassie, I will drop these links into the chat so that we have a nice long record of all of these things. And I will include that paper that I started off with from Dr. Mike Wimberly, so that everybody has that as well, because it is a great, incredible resource it should be open to and accessible to, I'd say, a higher secondary education, high school sort of audience should be able to understand that and put their activities within this context. And it really sets the foundation for how to use satellite data together with mosquito data. So I will definitely do that, Cassie.
Again, thank you very much, Peter. And I'm going to share Inês and get her ready then.
Hello, my name is Inês Mauad. I'm a science teacher from Minas Gerais School in Brazil. Minas Gerais School is a middle school in the Rio de Janeiro. It's an urban area surrounded by trees, the beach, and streets, and a small building. And I have in the science club students from 9 to 15 years old. Can train. Hello, everyone. My name is Inês Mauad, and I'm a science teacher from Minas Gerais School in Rio de Janeiro, Brazil. Me and my science club students, we came to space to look for mosquito data. I'm kidding, because we know mosquito breeding sites only be seen on the ground. We are here to show some small videos we made in this quarantine. In the videos, you can see how to collect data and destroy mosquito breeding sites. We also teach how to make a homemade traps using a soda bottle and how to identify mosquito using Mosquito Habitat Map. Come to see what we did in this quarantine.
everyone, my name is Luiz Eduardo Freitas. My team is the Science Club for Minas Gerais School in Rio de Janeiro, Brazil. Our teacher is Inês Mauad. How to collect data from disease-transmitting mosquitoes in quarantine for COVID-19 pandemic, and what genus of mosquitoes is most frequent in our home.
In these videos, we saw some short animation made from the students in the pandemic times. We did together, each one in their house, collecting data, but we are collecting data and photographing the traps. And I said, we can do something extra to show to school, because in our school we have the small and the big ones. So the big ones show and teach for the small ones, because we have elementary school and middle school. So the science club go to the other classrooms to teach, to show, to make easy for them to be a science citizen. And we made with Beetle app, Beetle able, because it's free. We don't need to pay. So I hope you enjoy.
Thank you so very much. That was so so wonderful to watch, and all the activities that you've shared with our participants and our community of what could be done both during pandemic times and both before and afterwards, but wonderful experiences for all your students. If there are any other questions in the chat, I know that there's lots of comments about using Bitable. It was perfect. It's just the right size video segment to put together. And I'm doing all the talking, but I know that the other panelists have some things to add too. But the depiction of the mosquito with all the proboscis, the tools and everything, the 6 layers, that I thought was great. It was a nice way to incorporate all of that.
Yes, and we made the stories with the characters they have. So it's easy, and the students say, we can, this one can be the mosquito, this one can be the student.
Mm-hmm.
They really like.
Yeah, it's wonderful. Thank you so much for showing us this. And it's something that basically any teacher could use this kind of software and engage their students in telling these stories.
Yes.
So I really enjoyed it. And it was super cute, Inez. Thank you so much. With lots and lots of great data in there. And you weren't reading the chats, but I was saying thank you for stressing that zeros are data. Be happy when there's no mosquitoes in your trap, but just report a 0. And your work has paid off in terms of the mosquito habitat mapper. I really appreciate it.
We said they were sad because sometimes they call me and said, oh, I'm so sad. There is no larvae here. There is no mosquito. I said, it's okay because you were cleaning your house.
Wonderful.
Absolutely. Well, again, thank you so much. And to those of you who have joined us, we're looking for our next featured presenter. If you'd like to share an activity or what your students are doing with Mosquito Habitat Mapper or with land cover, please contact me. My information was in the invitation to join this webinar, or you can go out to our Mission Mosquito webpage on globe.gov, find our email addresses. But we'd love to showcase what you've done, just like we did with Inez. She set the bar high, but I know that there's lots of great opportunities and activities going on all around that we'd love to share. I do thank you very much for spending an hour today with us, and hope you enjoyed it as much as I did.
Thank you, Cassie. You did a wonderful job moderating. I just want to thank our guest speaker, Peder Nelson, for taking the time today to think about land cover in the context of mosquitoes. That's not his primary interest, but he showed us how that water data really works. And I know we're all excited to see what's going to happen with the new Landsat 9 data when it starts coming in, and we can start looking at it in December. We'd like to invite him back maybe sometime early in the new year to begin to look at that data. So if you're willing, Peder, we'd love to see that.
I look forward to it, and it's going to be an amazing year when we all start looking at this new data coming down. So I just appreciate everybody coming and hopefully getting inspired and being part of my enthusiasm about the new science and the continuation of this generational science that we're doing, not only from space, but also in the GLOBE program here together. So thank you all for allowing me to come in and share what I am passionate about.
Thank you.
Thank you.
And join us next time, where we'll have a graduate student from Kansas State University talking about her experience with big data. So that'll be a great way to kind of segue into the data part. So again,
right. And I also want to stress too that she's going to talk about just getting started with big data, right? Which I think is one reason we really wanted to invite her, because she's going to help us sort of get around that hurdle of just getting started. And she is an author of a really compelling blog that we will link to in the next session. But we're really looking forward to having Victoria talk with us. So we look forward to seeing you then.
All right. Again, thank you all so much for joining us. See you next month.